As we know that basically there are two types of network protocol. One is TCP/IP protocol. Another one is UDP protocol. So TCP/IP protocol is nothing but connection-oriented protocol. So connection-oriented protocol, as we know that is more reliable because that is physical connection of the cables or wires between source system and sender system. So that's why there will be connection. There will be connection oriented. So connection oriented is always more reliable, and the UDP, as we know that connectionless protocol. So for wireless communication, UDP will support. So that is less reliable compared to TCP/IP protocol. Now, and also IP is nothing but internet protocol. So internet protocol is used for communication, used for creating communication between source and destination devices without wires and cables. So through air protocol, ARP protocol only, so communication will be established and transferring files or data, right? And also in previous classes we have discussed what is packet, what is packetizing, right? So packet is nothing but information, right? So that is a standard format for transmitting the data in wireless communication in virtual local area network, right? So in a packet, packet header will be there. So in the packet header, actually there are three contents will be there. One is our data, actual information. Second one is source address. Third one is destination address. Right. These three information will be available in the packet. Right. So packetizing means how to transmit the packet from source to destination using internet protocol. Right. So one popular internet protocol we have discussed, that is IPv4 protocol. Right. So IP, the main IP internet protocol is the main protocol. The standard protocol of internet protocol is IPv4. We have discussed in the previous section what is the architecture of IPv4 and what are the contents of the IPv4 in previous classes we have discussed. So IPv4 is responsible for packetizing, forwarding and delivery of a packet at the network layer. Right. So these are the responsibilities of IPv4. So packetizing, as I told you, how to transmit the packet from source to destination using intermediate nodes, that is hop counts. Right. So depends on number of intermediate nodes, we will calculate number of hops, right? Second one is forwarding. So forwarding means if the distance is more in wireless communication, right, then number of intermediate nodes will come. So in that way we will calculate how many number of apps, as I told you, right? So there between source and destination some intermediate nodes, mobile nodes will come. That mobile nodes, how they will forward the data from source to destination, that is called as a forwarding technique, and delivery of a packet at the network layer. The internet ICMP, right? ICMP also in some concept we have seen, that is internet control message protocol version, that is ICMP v4 helps to IPv4 protocol, right? So internet control message protocol will help to IPv4 to handle some errors. Dear students, in last class we have discussed what are the different types of error, that is flow control, congestion error control, right? And error flow. So these are some errors will appear in the networking when there is any communication will be established between source and destination, right? So ICMPv4 is help to IPv4 to handle some network errors in the network layer delivery, right? The and one more internet is there, your protocol is there in the network layer, that is IGMP, internet group managing protocol, is used to help IPv4 in multicasting technique, internet technique, right? So unicasting and multicasting technique, right? So as we discussed in the previous section, between source and destination, multiple any number of paths can be connected. Right there, one is unicasting, second one is multicasting. Unicasting means selecting only one path, right, creating and selecting only one path between source and destination. Multicasting means, so from source to destination there are multiple paths will be established and connecting to transmit the data, right. So packet can be transmitted through any path to the destination, that is called as a multicasting. So multicasting is always better, because if any path will be lost because of signal strength or any reason, then other path will be immediately, other path will be selected for transmitting the data. So there will not be loss of any path in the multicasting. So IGMP protocol, Internet Group Management Protocol, will be supporting for IPv4 in multicasting networking. And also the address resolution protocol, ERP, is also very important protocol. So address format also we have discussed in the network layer, right students. So for address specification, for selecting source address and destination address, there is one standard protocol, that is the address resolution protocol, right. It is used to glue the network and data link layer in mapping the network layer addresses to link layer address, right. So network layer will come between link layer and data link layer. So how to map the address, right, between data link layer and network layer, and between network layer and link layer. So this address resolution protocol will be supporting for IPv4 to map the address between data link layer and network layer and link layer. So these are the responsibility of the internet protocol. So I will conclude it, summarize it. So the standard protocol in the internet network layer is IPv4, right. Again, there are three different protocols will be support for IPv4 for different purpose. So one is ICMP, Internet Control Message Protocol, for handling errors, and Internet Group Management Protocol is used to help IPv4 in multicasting, right. ERP protocol is used to address the map between data link layer and network layer, and network layer and the link layer for the address purpose, right. So this is the standard format of the IP structure. Now we can see that where is the IP address and what is the position of IP and other network layer protocols in TCP/IP protocol suite, right. So where is IP, right. So and what is the function of IP, we can see in this black diagram. I will explain you. IPv4 is an unreliable, as I told you. So internet protocol through air only, this is connectionless. Of course IPv4 is connectionless protocol and 32-bit address, you should remember that, right. So if it is connectionless, so definitely we can say that unreliable datagram means there is no guarantee to deliver the data to the destination in connectionless. So because there is no proper mean specific cable or wire connection will be established between source and destination. Through air only, through intermediate nodes only, source will transmit the packet. So that's why that is unreliable data. So IPv4 is connectionless, right, and a best effort delivery service. Compared to any other protocol, IPv4 can do the best effort delivery service. The term best effort means that IPv4 packets can be corrupted, be lost, arrive out of order, or be delayed and may create congestion for the network, right. So best effort means if there is any corruption of the data, right, and if data is lost, and if data is out of order, and if data takes more delay to transmit the data, and if there is any congestion in the network, then IPv4 can handle all these situations and problems. So that's why IPv4 is called as the best effort protocol in the network layer. If reliable is important, right? IPv4 must be paired with a reliable transport layer protocol such as TCP. Students, as I told you, IPv4 is connectionless protocol and it is an unreliable datagram protocol, right? How to avoid this unreliable datagram protocol? So if IPv4 will be supported by TCP protocol, TCP is connection oriented, right? So IPv4 is connectionless protocol. If it is paired with a TCP IP protocol, then IPv4 will become more reliable datagram protocol. Right, IPv4 is completely connectionless protocol. If it is paired with TCP protocol, then IPv4 will become connection oriented protocol. Then we can say that IPv4 is also reliable protocol, right? Good reliable protocol. Then IPv4 is also a connectionless. As I told you in the beginning, IPv4, of course, connectionless protocol. It means that is datagram approach. See, in previous classes, we have discussed that there are two types of connection, means protocols. That is, first one is datagram approach. Second one is virtual circuit approach. So datagram approach means connectionless only. Virtual circuit approach means connection oriented only. In forwarding technique, we have discussed there are two ways of the approaches. First one is datagram is nothing but connectionless, and second one is virtual is nothing but connection oriented. So is handled independently, right? So each datagram is connectionless, is handled independently, and each datagram can flow a different route to the destination, right? So in virtual circuit approach, right? So each packet will be related with among all the packets. But in datagram or IPv4 protocol, one protocol is not related to another protocol, right? And also in virtual circuit, only one path will be selected. In virtual circuit approach, right, means connection oriented method, only one path will be selected for any number of packet will be transmitting from source to destination. But in datagram approach or connectionless protocol, there are n number of paths will be established, and packets that can that can transmit from source to destination in any path. There is no any specific path will be created. In any path, packet will be delivered to the destination. So that is called as IP4 datagram approach, right? Then IPv4 relies on a higher level protocol to care of all these problems. As I told you, IPv4 will take the help of ICMP, IGMP, and ERP protocol, and also TCP/IP protocol for handling that loss of data, corrupted data, out of order of packet, more delay, and for the congestion control. So all these problems, issues will be sorted out when IPv4 will be will take the help from other protocol with TCP, ICMP, and IGMP protocol. Right now, so now let us discuss this TCP/IP suite. So this black diagram, we can say that TCP/IP protocol suite. So there are five protocols: application layer, transport layer, network layer, data link layer, and physical layer. Right. So this is open source interface protocol. In application layer, SMTP, simple message transport protocol, file transfer protocol, that is FTP, telnet, DNS, SNMP, right? All these protocols are presented at the application layer protocol. At the transport layer, what are the different protocols are there? SCTP protocol is there, TCP protocol is there, and UDP protocol is also there. So transport layer is having both connection oriented and connectionless protocol. Now at the network layer, as we discussed in the introduction of the network layer, IGMP, Internet Group Message Protocol, ICMP, Internet Control Message Protocol, and IP, Internet Protocol. So we can see that where is the position of Internet Protocol. So Internet Protocol is presented at the network layer with the support of IGMP, ICMP, and ERP protocol, right? So completely all network layer protocols are connectionless protocols, but with the support of TCP, so network layer will also provides more reliability in the network. Right, then data link layer and physical layer are the bottom layer. Right, underlying local area network or wide area network technology can be used. Please try to understand this block diagram. This block diagram is very important. You can understand that. So what are the open source interface layers? Right, application layer, transport layer, network layer, data link layer, and physical layer. And what are the different types of protocols are present in each layer? This is very important. Now let us discuss what is datagram format in the network layer protocols. Right. So packets used by the internet protocol are called as datagrams. Right. So what is the meaning of datagrams? Right. So if packet used by the internet protocol, then that is called as a datagrams. Right. So packet contents are source node address, destination node address, and actual contents, which will be transmitted from source to destination. These three content will be there in the packet header. So again, I'm telling you, in the packet header, there are three information will be available. One is actual data, which will be transmitting from source to destination. Second one is source address. Third one is destination address. Now one more format is there in the network layer protocol, that is called as a datagram. So what is datagram? If packet is used by internet protocol are called as datagrams. Right. Then a datagram is a variable length packet consisting of two parts, that is called as header and payload. Right. Dear students, header, as I told you, header will be there inside the packet. Means the main content of packet is header only. Right. The content of header is actual data, source and destination address. And one more part is available in the datagram, that is called as a payload. So payload is nothing but data only, right? That the header is 20 or 20 to 60 bytes in the length, right? But length and contains information essential to routing and delivery. So what is the functioning of datagram? Datagram, the main function of the datagram is for routing and delivery purpose. So routing means creating path between source and destination. Then the routing table will be keep on updating all the data when the network is established. Routing table automatically update all the information between source and destination, including address. So it is customary, datagram is customary in a TCP IP to show the header in 4-byte connections. Of course, that is 32-bit address. IP address is 32-bit address only. Right. So this is internet protocol datagram structure. As we told that the header length from 20 to 60 byte, 60 bytes, that is called as a header. Then payload from 60 to 65,535 bytes, right? Then VR variable and header length is there, service type 8-bit, total length, so identification of 16-bit, flag 3 bits, all those source IP address is 30-bit, destination IP address is 32 bits, options plus padding 0 to 40, any information, any protocols we can add into at the bottom layer. So this is the structure of the internet protocol datagrams. Now, what is fragmentation? This is another concept. Another concept in the network. What is fragmentation? Dear students, please understand what is packet, what is datagram format,